Okay, greetings grade 9s and my other students. So this is a quick review on 4.3. That's another or other equations for linear relations, starting with vertical lines. And as you know, or if you remember, vertical lines are actually x equals something, where a is any number. Okay, I don't have to write it down, but if you remember it, that's great. Okay, so what I think we're going to do is, in this video, we're just going to give you an example where we actually have to solve an equation, and for a vertical line. Okay, so let's say you get an equation that looks like this: 3x plus 6. Let's make that equal to 0. It doesn't have to be 0, but let's just keep this simple. Okay, and immediately, if you see an equation that only has an x on it with no y, then you should automatically see that this is actually a vertical line. But we have to solve this equation. We've got to clean it up to make it look like x equals something. So what is that x equals something going to be? Okay, and I'm hoping, I know I might be assuming a lot here, but this kind of solving equation is actually been done since grade 7, and it's been done in grade 8, and we'll do it again here in grade 9. But I know we're not in the solving equations unit yet, but this should be a simple two-step equation, right? So what should I do first to solve or isolate this x, or magic number, by itself? Well, the last thing we did to it was add a 6. So we're going to subtract 6 first. When you do it on one side of the equation, you got to do it in the other. Okay, so now here I have 3x equals, and 0 minus 6 is -6. And now, how do we clean this up? How do we finally finish this? Well, this is a multiplication. Whatever this number is, I multiplied it by 3, so we're going to reverse that by dividing both sides by 3. Okay, so that cancels out the 3's on this side. And on this side, we're left with just -6 divided by 3, which is -2. And there's our equation. Okay? So now, just to get this part over with, how do you describe this x equals -2, or this vertical line? Well, this is your description, and you can use this template. X equals -2 is a vertical line that intersects the x-axis at -2. Okay, that's your description. And now how do you graph this? Well, I'm going to make a crude graph over here, and please do not make crude graphs. When you're graphing your questions from your assignment, do not use a loose leaf like I'm doing. This is just a crude graph because I'm just doing this for demonstration purpose. But when you do the assignment, please use graph paper. I've got lots. Well, here's my, my graph paper, quote unquote. Where is my vertical line when x equals -2? Well, I'm going to look for x equals -2 on the x-axis. There he is. And that is going to be a vertical line here. Okay? So again, when you're graphing, though, make sure you're labeling your axes and make sure you're using correct, appropriate intervals for your graph. Okay? So that's that's vertical lines. So now let's do the horizontal lines. Put this up here a little bit, horizontal lines. Okay, and horizontal lines, are, well, the other way. Well, it's y equals a. And without writing down, a can just be any number. It could be an integer, it could be a fraction, it could be a decimal. Okay? So now let's give you another example here. This time of an equation of a horizontal line. What about this one? -8 minus 2y equals 4. Oh, pardon me, -8 minus 2y equals 4. Let's make this a negative actually. There we go. Okay. I know this doesn't look like a y equals something, but that's what we're going to have to do. Y equals what? Okay, so we got to clean up this mess. Get this y by himself. Okay, again, this is solving equations. So what do we do first? Well, we got to get rid of this. I sometimes call him the dangler. In math, he's called the constant. So we got to get rid of him first. How do you get rid of a -8? Well, you add 8. If you do on one side of the equation, you got to do on the other. Okay, so that gets rid of this -8 over here, pardon me, the -8, so you're left with -2y on this side, and -4 plus 8 here is +4. Okay, and now again, last, this is a multiplication, so -2 times y, how do you reverse that multiplication? Well, you divide both sides by that -2. And now you're left with y equals -2. And there's our equation for the horizontal line. Okay? So let's give this a quick description. Y equals -2 is a horizontal line. Oops. That intersects the y-axis at -2. All right, so if it intersects at -2, well, what does that look like in a graph? Again, crude graph, just for demonstration purpose on loose leaf. Don't do this in your assignment, please. But we'll just go 1, 2, 1, 2, -1, -2, and -1, -2. Well, here's my y-axis, and it's going to intersect, it's a horizontal line that's going to intersect the y-axis somewhere. And we said it's going to intersect it at -2. So here's my y equals -2, and we're going to draw our horizontal line right here. Okay, so this is y equals -2. Oh, I forgot to draw that up here. This is x equals -2. Okay. So there's your quick review on vertical and horizontal lines. Okay. You know, oblique lines, they actually have, remember oblique lines actually have both y and x in their equation. Okay, so let's do that really quick, oblique lines. In other words, these are slanted lines, okay? Slanted or sloped lines, okay? So, for instance, in a graph, they might, you know, these are any lines that, you know, might go in this direction or this direction. These are all slanted lines, these are all oblique lines, okay? But the example I'm going to give you is this one. Y equals 3x plus 2. Notice with oblique lines, they have both x and y in their equation, okay? So this graph here might look a little something like this. Okay, well, you know what? Why don't we make a data table for it? Just for quick review's sake. 0, 1, 2, 3, 4. When x is 0, 3 times 0 is 0. 0 plus 2 is 2. Okay? Maybe I should show that calculation. When x is 0, 3 times 0 is 0, and 0 plus 2 is 2. And so that's where I get the 2 there. When y equals 1, pardon me, when x equals 1, 3 times 1 is 3. 3 plus 2 is 5. Okay? And maybe we'll do one more, but we can actually see this is actually increasing by 3, right? Well, we'll do one more. When y equals, oh, pardon me, when x is equal to 2 now, y equals 3 times 2 plus 2, this will be 8. And so I'm going to predict that the next one is going to be 11. And one after that will be 14. Okay? And now I can actually graph this. And again, please forgive the crude graph on loose leaf. Just a reminder, do not do this on your assignments, okay? Actually, I'm going to do this. Well, most of our value is going to be in a quadrant 1, so I'm going to do this, x, y, okay? And I'm going to go 1, 2, 3, 4, 5. And over here, I'm going to make this, I guess I should have used this as 2, 4, 6, 8, 10, 12, and 14. There we go. And we're ready to plot these points. Okay. The first ordered pair or set of data is 0, 2. 0 on the x is right here, and 2 is up here. And then 1, 5 is, I believe, right here. Again, hopefully this comes out straight. 2, 8 is over here. Just trying to make a straight line. 3 and 11 will be right here. And I'm going to do this one last 4, 14 is right there. Okay. And there's your oblique lines. Okay. I guess one last thing we should probably review is a solid line versus broken line. Okay. This time I'm just going to give you an example. Okay. So I'm just going to read this out to you. How do you know when to make a solid line? Well, it depends on the question that you're doing. In this case, in this example, for instance, if somebody was biking at 6 meters per second, so cycling on a bike at 6 meters per second, well, that's a measured comparison of relation between distance and time. This will be continuous. It will be an indiscrete data, and you are allowed in-betweens here. For example, okay, so if I was to plot this, I made a quick data table here. 1 second it'll travel 6 meters, 2 seconds 12, 3 seconds 18, etc. 4 seconds 24. So this is increasing by 6. So d then will be equal to 6 times t. Okay, so and then I plotted this graph. So again, very crudely, okay, in 1 second he went 6 meters here, okay, in 2 seconds he went 12, which is right here. 3 seconds he went 18. So there's my original plot. But notice these guys, you know, they're not in a data table by any means. This is like half a second. Well, there is in between allowed here. So for example, and this is the kind of examples you have to give me when you tell me that you're allowed to make a solid lines graph. So when you say there's in betweens allowed here, you got to give me an example. Like, so in between 0 and 1 there's a half a second, and the distance for that for this cyclist would be 3 meters. There is a 1.5 second, as in here, and the distance for that would be 3 meters, pardon me, 9 meters. Okay? An example where you're not allowed, let's say, a dotted or broken line. For example, okay. A dotted line graph, let's say, would be an example. Let's say, I've mentioned this in class. Let's say you're buying fish. Okay? So this is the number of fish that you want to put in, let's say, in your aquarium, and the cost for each fish is, let's say, $4. Okay. Okay. So 1 fish, 2 fish, 3 fish, 4 fish. Okay. So the graph might look like this. Okay. 1, 2, 3, and 4. Okay? So it is a straight line, but there is no in-betweens allowed. Why? Because you cannot ask them to give you 1.5 fish to put in your aquarium. Get it? This is not a situation where you can actually buy that. Okay? They're not going to give you. They're not going to cut a fish in half and then give it to you and put it in your aquarium. So this would have to be broken line. This continuous data table, and it will be discrete, where each plot and points is just by itself and there is no in-betweens allowed. Okay? So hope this helps, and I know you can pause and rewind the video. I know it's a little long, but at least it's a good, we've finally got a video for 4.3, and I hope it does help you. And if you have any questions, bring it in class and I'll be glad to help you out. Okay? Bye-bye for now.